Welcome to our lesson on chemical formulae, equations, and calculations. This chapter is essential for understanding quantitative chemistry. In chemistry, knowing the exact amount of substances that react is crucial for success in the lab and beyond. We'll cover writing and balancing chemical equations, understanding relative masses, introducing the mole, and performing essential chemical calculations. To figure out how much of one substance reacts with another, we must use the mole concept. This allows us to quantify the massive number of atoms in a sample. Let's start with the fundamental language of chemistry, equations. You'll need to know two types: word and symbol equations. Symbol equations, often called chemical equations, are the standard. All chemical equations, regardless of the type, must be balanced to obey the law of conservation of mass. Adopt a systematic approach to balancing. Work from left to right, leaving elements appearing in multiple places until the end. Crucially, only change the coefficients, never the formula itself. Atoms are tiny, so we use a scale of relative masses to make calculations manageable. This leads us to the critical mole concept. Relative atomic mass, A sub r, is the weighted average mass of isotopes. Relative formula mass, M sub r, is the sum of the A sub r values for all atoms in a compound. The mole, abbreviated as mmol, is the standard unit for the amount of substance. 1 mole of any substance has its own specific mass, which we call the molar mass. You must be able to convert between a mass in grams and an amount in moles. Remember the simple formula. Number of moles equals mass in grams divided by the mass of 1 mole in grams. Next, let's differentiate between the two main types of chemical formulae we encounter: empirical and molecular formulae. The empirical formula shows the simplest whole number ratio of atoms, while the molecular formula shows the actual number of atoms in a molecule. The molecular formula is always a multiple of the empirical formula. To calculate the empirical formula from experimental data, you first convert the mass or percentage of each element into moles, then divide by the smallest number of moles to find the simplest whole number ratio. Now we apply the mole concept to chemical equations to perform mass-to-mass calculations and determine percentage yields. The coefficients, or big numbers, in a balanced chemical equation represent the mole ratio in which substances react. For example, 1 mole of methane reacts with 2 moles of oxygen. We use a 3-step method for mass-mass calculations. First, convert the given mass to moles. Second, use the mole ratio from the balanced equation to find the moles of the substance of interest. Third, convert those moles back to mass. Percentage yield tells us the efficiency of a reaction. It's calculated by dividing the actual yield, what you got in the experiment, by the theoretical yield, multiplied by 100. We have covered the foundational elements needed for chemical calculations. Mastering these concepts is key to your success in chemistry. Remember the importance of balancing equations, calculating relative formula masses, and using the mole concept and mole ratios for stoichiometric calculations. Join us for the next chapter where we will delve into more complex calculations, including those involving solutions and gases. Thank you for tuning in.